Hello there, welcome back to my channel. This is Walter here, taking you through another pure mathematics paper once again. Today we have the October-November 2020 paper. This is paper 13. So let's get started. On question number 1, part A, express x squared plus 6x plus 5 in the form x plus a squared plus b, where a and b are constants. So here, all they want you to do is to perform completing the square. So what I'll do is I'll open up my bracket, then I put the square root of x squared, which is x, then it's plus half of the coefficient of x. The coefficient of x is 6, so half of that is 3. Then squared, then we subtract the 3 squared, then it's plus 5. So this eventually gave us x plus 3 squared, and this is minus 9 plus 5, which is minus 4. So this is what we get. Let's go to part B. On part B, they say the curve with the equation y is equal to x squared is transformed to the curve with the equation y is equal to x squared plus 6x plus 5. Describe fully the transformations involved. So here I'm going to say let f of x be equal to x squared, which therefore means that for the equation y is equal to x squared plus 6x plus 5, which we also expressed by completing the square, we got this to be x plus 3 squared minus 4. So this is the same as x plus 3 squared minus 4. So we can say that for x plus 3 squared minus 4, in function notation, we can write that as f of x plus 3 minus 4. So we now have the equation y is equal to x squared plus 6x plus 5 in function notation as f of x plus 3 minus 4. So now that we have it this way, so we can now say this part represents a translation by minus 3 units in the x direction. And the second transformation, represented by minus 4 here, is again a translation by minus 4 units in the negative y direction. So this is what we get. Let's scroll down to the next question. Question number 2. The function f is defined by f of x is equal to 2 over x plus 2 squared for values of x that are greater than minus 2. So on A, find the integral from 1 to infinity of f of x with respect to x. So for this one, I'm going to start by integrating from 1 up to k the function f of x with respect to x. So this means that we'll be having the integral from 1 up to k of 2 over x plus 2 squared, which I can write as 2 of x plus 2 to the power minus 2 with respect to x. So integrating, I'll be having the 2 of x plus 2 to the power of minus 2 plus 1, which is minus 1, all divided by minus 1. And we have our limits here, that's from 1 up to k. So this can be expressed as minus of 2 over x plus 2 with our limits. So this is just another way of expressing it. So this is what we now have. And we can simplify this to, substituting k, we'll be having minus 2 over k plus 2. And substituting 1, we'll be having minus of minus, so we have plus 2 over 1 plus 2, which is 3. So this is what we now have if we integrate with the limits 1 and k. Now, I want you to notice that as k approaches infinity, the 2 over k plus 2 approaches 0. you see as k increases, if the denominator increases here, then this whole algebraic fraction begins to decrease as it approaches 0. So we can say as k approaches infinity, we'll be having minus of this whole thing, which becomes 0 eventually, and that's plus 2/3. And we get our final answer as 2/3. So that's how we do it. Let's scroll down to part B. The equation of a curve is such that dy by dx is equal to f of x. It is given that the point -1, -1 lies on the curve. Find the equation of the curve. Okay, so we have the fact that dy by dx is equal to f of x. So in order for us to get the equation of the curve, we have to integrate both sides from this. So if we do that, we'll be having y coming out as the integral of f of x with respect to x. Now, we had already integrated f of x on part A, because when we integrated f of x, we got something like -2 over x plus 2. So let's make use of that. So the integral of f of x gives us -2 over x plus 2. And that's plus c. Now, since the point -1, -1 lies on the curve, then we can substitute these points into the equation of the curve in order for us to find the constant of integration. So that means we'll be having -1 being equal to -2 over -1 plus 2 plus c. So -1 is equal to -1 plus 2 is 1. So -2 over 1, that's -2, that's plus c. So here eventually we get c coming out as 1. Therefore, the equation of the curve comes out as y is equal to -2 over x plus 2 plus 1. And this is the final answer. Question number 3. Solve the equation 3 tan squared theta plus 1 is equal to 2 over tan squared theta for values of theta between 0 degrees and 180 degrees. So what I'm going to do with this one is I'll start by multiplying all the terms by tan squared theta. So if I do that, here I'll be having 3 tan to the power 4 of theta, and 1 times tan squared theta, I'll be having tan squared theta here. And here, multiplying by tan squared theta, we just get 2. So taking everything to one side, we'll be having 3 tan to the power 4 of theta plus tan squared theta, that's -2 equal to 0. Now I'm going to say at this stage, let y be equal to tan squared theta. So therefore, it means we'll be having 3y squared plus y minus 2 is equal to 0. So I can factorize this. So factorizing here, this I'll be having 3y and y here, then -2 and plus 1 here, which therefore means that we can say either 3y minus 2 is equal to 0 or y plus 1 is equal to 0. So we get y coming out as 2/3 or y coming out as -1. Now, since we had used the substitution y is equal to tan squared theta, this is going to mean, therefore, replacing tan squared theta for y, tan squared theta is going to be equal to 2/3. And here, tan squared theta is going to be equal to -1. Now, for this part, we're going to have no solution. And the reason for that is, if I square root both sides, then whatever I'm going to get is going to be imaginary. We're not going to get a real solution. So we're going to focus more on tan squared theta is equal to 2/3. So I'll square root both sides to get tan theta is equal to plus or minus the square root of 2/3. Now I'm going to find the value for theta here by saying theta is equal to arctan of the square root of 2/3. So let's make use of our calculator for this. So that's shift tan of the square root of 2/3. And I'm getting 39.2 degrees. So that's theta is 39.2 degrees. Now, if I consider the quadrants, I think you can notice that theta will have a value in all the quadrants since tan is both positive and negative. But according to the question, they want us to find a value of theta within the range 0 to 180 degrees. So the only two quadrants where we're going to have a value for theta are the first quadrant and the second quadrant. So in the first quadrant, theta is going to have a value of 39.2 degrees. And in the second quadrant, theta is going to have a value of 180 minus 39.2. So that's 180 minus 39.2 degrees. So here we are saying theta has values 39.2 degrees. And what's 180 minus this? That's 140.8. So 140.8 is the other value. And these are the two solutions. Question number 4. A curve is equation y is equal to 3x squared minus 4x plus 4, and a straight line is equation y is equal to mx plus m minus 1, where m is a constant. Find the set of values of m for which the curve and the line have two distinct points of intersection. So here I'm going to equate the equation of the curve, which is 3x squared minus 4x plus 4, to that of the line, which is y is equal to mx plus m minus 1. And I'm going to take everything that is on the right side to the left side. So I'll be having 3x squared minus 4x plus 4, and that's minus mx minus m and plus 1 equal to 0. So I can regroup the terms. So I start with 3x squared. Then we have minus 4x and minus mx, which is minus of 4 plus m of x if we factor out the x. And then for the constants, we have 4 minus m plus 1. Now 4 plus 1 is 5. So we'll be having 5 minus m here, and that's all equal to 0. So since they say that the curve and the line have two distinct points of intersection, then we know that b squared minus 4ac should be greater than 0. And here a is 3, b is minus of 4 plus m, and c is 5 minus m. Okay, so for b squared minus 4ac, we'll be saying that's minus of 4 plus m squared minus 4 of 3 of 5 minus m. So this is the discriminant, and it's going to be greater than 0. So let's simplify this. Expanding 4 plus m squared, we get 16 plus 8m plus m squared. And here minus 4 times 3 is minus 12, and minus 12 times 5 is minus 60. Then minus 12 times minus m, that's plus 12m, and that's going to be greater than 0. And we can rearrange this to have m squared, then 8m plus 12m, that's going to be 20m, and 16 minus 60, we get minus 44, and that's going to be greater than 0. Now this can be factorized, and if we do so, we have m here and m here, and factors of minus 44, whose sum is 20, are going to come out as plus 22 and minus 2. So we now have it factorized. Now here we have the critical values which occur when m plus 22 is equal to 0. So m is equal to minus 22. And when m minus 2 is equal to 0, that's m is equal to 2. So to find the set of values, I prefer to use the graphical method. So with the graphical method, I'll be having here, this is like the m, and we have it like this. So here we've got minus 22, and here we've got 2. Then this is positive above and negative below. But here we're saying that this function of m is greater than 0, which means we want values of m that are less than minus 22. That's where this quadratic function is above the m-axis or positive. And also, we want values of m that are greater than 2. That's also where this graph is greater than 0 or positive. So this is the set of values of m. Let's go down to the next question. Question number 5. In the expansion of a plus bx to the power 7, where a and b are non-zero constants, the coefficients of x, x squared, and x to the power 4 are the first, second, and third terms, respectively, of a geometric progression. Find the value of a over b. So right here, we're going to consider the binomial. That's a plus bx to the power of 7. And we know that the general term of this binomial expansion is going to be given by 7 choose r, a to the power 7 minus r, and bx to the power of r. So we can also express this as 7 choose r, a to the power 7 minus r, then b to the power r, and x to the power of r. So the first term should be 7 choose 1, a to the power of 7 minus 1, which is 6, and b to the power 1. So I'll just write the coefficient part of it. So this is what we have for the first term of the geometric progression. Then for the second term, this is the term which is the coefficient of x squared. So it means r is going to be equal to 2. So that's going to be 7 choose 2, and that's of a to the power of 7 minus 2, which is a to the power of 5, and then b to the power of 2, so that's b squared. So that's the second term of the geometric progression. Then for the third term, which is the coefficient of x to the power 4, it means that the power r is 4, so that's 7 choose 4 of a to the power of 7 minus 4, which is 3, and that's b to the power of 4. So we now have the 3 terms of the geometric progression. Now we can simplify this a bit. Now 7 choose 1 is 7, so it's 7 a to the power 6 of b. And 7 choose 2 is 21, so that's 21 a to the power 5 b to the power 2. And 7 choose 4, that's 35, so we have 35 here, a to the power of 3 b to the power of 4. Now what we know about geometric progression is that if we divide a term by the one that is preceding it, we get r, which is the common ratio. So it means here, if we divide 21 a to the power of 5 b squared by 7a to the power 6 and b, this should be equal to 35 a to the power of 3 b to the power 4 divided by 21 a to the power of 5 b to the power of 2. So let's simplify this a bit. So 7 gets into 21 3 times, and a to the power of 5 divides into a to the power 6 to give us 8 power 1 at the bottom, and b gets into b squared to give us b to the power 1 at the top. So what we remain with on the left side is 3b over a. And on the right side, we know that if we divide 7 into 21, we get 3, and 7 into 35, we get 5. Then 8 power 3 into 8 power 5, we get 8 power 2 at the bottom, and b to the power 2 into b to the power 4, we get b squared at the top. So what we'll be having is 5b to the power of 2, and that's going to be over 3a squared. So this is what we now have. So what I'll do here is I'll multiply both sides by a over b. And if we do that, then here we cancel out, so we're left with 3. And here, dividing b into b squared, we get b to the power 1. So we have 5b. And a into this, we get 3a. And finally, to get the value of b over a, let's just multiply both sides by 3 over 5. And if we do that, then here we are left with b over a. So that's b over a. And here we'll be having 9 over 5. So therefore, a over b, the one we want, is inverting. We get 5 over 9. And this here is the final answer. Question number 6. The function f is defined by f of x is equal to 2x over 3x minus 1 for x is greater than a third. So on A, find an expression for f inverse of x. So here I'm simply going to say let y be equal to f of x, which is 2x over 3x minus 1. So I'll make x the subject. So I'll multiply both sides by 3x minus 1. So this side by 3x minus 1, and this side again multiply by 3x minus 1. So I'll be having y of 3x minus 1 on the left side is equal to, this will cancel, so that'll be 2x here. So I'll be having 3xy minus y is equal to 2x. So that's 3xy, and taking 2x to the left side, we'll be having minus 2x, and I'll take y to the right side, becomes y. And I factor out the x, so it's now 3y minus 2 inside the bracket, and that's all equal to y. Which therefore means if we make x the subject, dividing both sides by 3y minus 2, we'll be having y over 3y minus 2. So if we interchange the variables, we'll now be having y coming out as x over 3x minus 2. So therefore, the expression for f inverse of x comes out as x over 3x minus 2. And that's the answer right here. Let's scroll down to part B. On part B, it says, show that 2/3 plus 2 over 3 of 3x minus 1 can be expressed as 2x over 3x minus 1. So here, we are saying, if we have these two fractions here, we can add them up by first finding the common denominator. And the common denominator here is 3 bracket 3x minus 1. So 3, dividing it into this denominator, we get 3x minus 1, and we multiply that by 2. So we have 2 of 3x minus 1. And that's plus, dividing this 3 of 3x minus 1 into the denominator, which is 3 of 3x minus 1, we get 1. And 1 times 2 is 2. So let's simplify this. Simplifying the bracket, we get 6x minus 2 plus 2 there. And then that's over, at the bottom, 3 of 3x minus 1. This is going to give us Here we've got 6x, because minus 2 plus 2 is 0. And at the bottom we have 3 of 3x minus 1. Now 3 divides into 6 2 times, so that we are left with 2x over 3x minus 1, and hence shown. Let's go to the last part, which is part C. On part C, state the range of f. Now the function f from the question is equal to 2x over 3x minus 1. And on part B, we had shown that this is equivalent to 2/3 plus 2 over 3 of 3x minus 1. So in order for us to determine the range of this function, we can say as x increases tending towards infinity, what happens to f of x? Now I think you can notice, if you look at this expression, that as x increases, you see that this whole fraction will tend towards 0. Since as the denominator continues to increase, holding the numerator constant leads to the whole fraction tending towards 0. So we can therefore say f of x will approach the constant 2/3 plus this thing will have a limit of 0. So we have a limit here for f of x, which is 2/3. So we can say that the range of the function f is going to be f of x having a value that is greater than 2/3. So that's the answer right here for part C. Question number 7. The first and second terms of an arithmetic progression are 1 over cos squared theta and minus tan squared theta over cos squared theta, respectively, where theta ranges between 0 and half pi. So on A, show that the common difference is minus 1 over cos to the power 4 of theta. Now we have these two terms which are consecutive terms of an AP. And we know that if we subtract this term minus this term, then we get the common difference D. So let's do that. So I'll have minus tan squared theta over cos squared theta, and I subtract 1 over cos squared theta. So this is what's going to give me the common difference. So let's simplify this. This is equal to, I have at the bottom here a common denominator, so that's cos squared theta. So I'll have at the top minus tan squared theta minus 1, and this is the same as minus of tan squared theta plus 1, and it's all over cos squared theta. Now we know from our identities that tan squared theta plus 1 is the same as sec squared theta. So it's more like we have minus sec squared theta over cos squared theta, which I'll write as divided by cos squared theta. And here we know that sec squared theta is like 1 over cos squared theta. And when we say divided by cos squared theta, that's the same as times 1 over cos squared theta. And this is going to give us minus of 1 over cos squared theta times cos squared theta gives us cos to the power 4 of theta. And this is the answer. Let's move on to part B. On part B, find the exact value of the 13th term when theta is equal to a 6th pi. So here we know that the nth term of an AP is found by a plus n minus 1 d. So here we'll be saying the 13th term is going to be a, which is the first term, and the first term is 1 over cos squared theta. So it's going to be 1 over cos squared theta, and that's going to be plus n minus 1, which is 12 of d, and we had gotten d to be the common difference. That's minus 1 over cos to the power 4 of theta. So let's put it here. So that's minus 1 over cos to the power 4 of theta. So let's simplify this. But now we've been given that theta is equal to a sixth pi. And we know that when theta has a value of a sixth pi, then cos of a sixth pi gives us root 3 over 2. And therefore, cos squared of a sixth pi should be us squaring this. So this should give us 3 over 4. And also, cos to the power 4 of a sixth pi should give us, we again square this, so we get 9 over 16. So if we apply this here, then we have the 13th term coming out as 1 over cos squared theta, which is cos squared of a sixth pi, which is 3/4. So it's 1 over 3/4, and that's plus 12 of minus 1 over cos to the power 4 theta, and cos to the power 4 of a sixth pi is 9 over 16. So it's minus 1 over 9 over 16. So this simplifies to 1 divided by 3/4 is 4 over 3. And this is 12 of minus 16 over 9. And this simplifies to 4 over 3. And then here we'll be saying 3 into 9, we get 3, and 3 into 12, that's 4. And 4 times minus 16, that's minus 64 over 3. And we know that 4 minus 64 is minus 60, and minus 60 over 3, eventually we get 3 into minus 60, that's minus 20. So the answer comes out as minus 20. And that's how we do it. Let's take a look at the next question. Question number 8. The equation of a curve is y is equal to 2x plus 1 plus 1 over 2x plus 1 for x is greater than minus a half. So on A, find dy by dx and d squared y by dx squared. So what I'll do first here is I'll write down the equation like y is equal to 2x plus 1 plus, here 1 over 2x plus 1, I'll write it as 2x plus 1 to the power of minus 1. So let's start with dy by dx. So differentiating 2x, we get 2. Differentiating 1, we get 0. And that's plus. Differentiating 2x plus 1 to the power of minus 1 means we bring down the minus 1. Then we differentiate inside the bracket and we get 2. Then we write down the 2x plus 1. Then it's minus 1 minus 1, so it becomes minus 2 here. So this is going to give us 2, and minus 1 times 2 is minus 2, and that's of 2x plus 1 to the power minus 2. So this is what we get for dy by dx. So therefore, for d squared y by dx squared, we are differentiating the first derivative here. So differentiating 2, we get 0. Here we'll be having minus 2. Then we bring down the minus 2, the power. Then we differentiate inside the bracket to get 2. Then we have the 2x plus 1 to the power of minus 2 minus 1, which is minus 3. So this is going to give us minus 2 times minus 2 times 2, that's 8, of 2x plus 1 to the power of minus 3. So these are the two solutions for part A. Let's move on to part B. On part B, they say, find the coordinates of the stationary point and determine the nature of the stationary point. Okay, so for the stationary point, we know that dy by dx should be equal to 0. So at stationary point, dy by dx is equal to 0. Okay, so here we have already found dy by dx, and we got that to be this. So for this expression of dy by dx, we are going to equate it to 0. So I can rearrange this equation to 2 of 2x plus 1 to the power minus 2 is equal to 2. And dividing both sides by 2, we'll be having 2x plus 1 power minus 2 is equal to 1. Okay, and this is the same as 1 over 2x plus 1 squared is equal to 1. And it's also the same as 2x plus 1 squared is equal to 1. So if I square root both sides, I have 2x plus 1 is equal to plus or minus 1. So therefore, solving for x, we'll be having that's minus 1 plus or minus 1 all over 2. Okay, so we have two values of x. So the values of x here are going to be minus 1 over 2. That's minus 2 over 2. So that's minus 1. Or minus 1 plus 1 over 2. Now minus 1 plus 1 is 0. So dividing 0 by 2, we get 0. So we have two x values here. Now since we have two x values here, x is minus 1 and x is 0, from the question, we had been told that x should be greater than minus a half. So the value of x that is greater than minus a half is 0. So we're going to take x to be 0 since, according to the question, x should be greater than minus a half. And if x is equal to 0, what is y? So if we substitute into the original equation here, and we substitute 0 into it, we're going to get y coming out as 2. So we now know that the stationary point is going to come out as the point 0, 2. Okay, now let us look at the nature of the stationary point. For the nature of the stationary point, we are going to use the second derivative, and for the second derivative, we had obtained this. So let's use this expression for the second derivative. So let's place it here. So this is d squared y by dx squared. So now that we have this expression of the second derivative, when x is equal to 0, d squared y by dx squared comes out as 8. And 8 is greater than 0, and therefore the point, we can conclude that the point is a minimum point. So that is the final answer. Question number 9. In the diagram, arc AB is part of a circle with center R and radius 8 centimeters. Arc BC is part of a circle with center A and radius 12 centimeters, where A or C is a straight line. So on A they say, find angle BAR. Now, angle BAR is this angle here. And if you consider the triangle ABR, you'll notice that it's actually an isosceles triangle where these two sides are equal. So if I draw a line from O, which is perpendicular to AB, it will certainly split AB into two 6 centimeter sides. So we can form a right angle triangle here where this side is 6 centimeters and we have another side of 8 centimeters. So making use of this right angle triangle, we can say the cosine of the angle BAR is equal to the adjacent side over the hypotenuse. So the adjacent side here is 6 centimeters and the hypotenuse is 8 centimeters, which means we can work out the angle BAR simply by saying arc cos of 6 over 8. So let's type that in. So that's shift cos, and that's 6/8. And here we get to three significant figures, 0.723. So we have our answer as 0.723. That's what we get. Let's scroll down to part B. On part B it says, find the area of the shaded region. Okay, so we have the shape here. Now, in order for us to find the area of the shaded region, we can say this is equal to the area of the sector. In this case, we're talking about sector ABC, and then that's minus the area of the triangle, and the triangle here is the triangle ABO. So let's make use of that. So for the area of the sector, we know the formula for area of sector. That's half times the radius squared times theta, where theta is in radians. So here we'll be saying half times the radius squared. For the sector, the radius is 12 centimeters. So it's half times 12 squared times theta. Theta is the angle we got. That's angle BAO. We got it to be 0.723. And that's minus the area of the triangle ABO. So for triangle ABO, we can make use of the formula for area of a triangle, half times side, sine the angle in between. So it's half times the side 12 times the side 8 times sine of 0.723. So let's type that in. So we'll be having 0.5 times 12 squared times 0.723, and that's minus half times 12 times 8 times the sine of the angle 0.723. And we're in radians, you have to make sure of that. And the answer here to three significant figures is coming out to be 20.3. So we have 20.3 coming out as the final answer right here, and that's in square centimeters. Let's scroll down to part C. Find the perimeter of the shaded region. So again, I'll have the shape here. So for the perimeter, I'll be saying perimeter of the shaded region is the length BO plus the length OC, and that's plus the length BC, which is the arc. Okay, let's start with BO. BO here is 8 centimeters in length, and that's plus OC. To find OC, we can simply say AC minus AO. So we know that AC is 12 centimeters, and that's minus AO, which is 8 centimeters. So that's OC. And then for BC, that's the length of the arc of the sector ABC. And for length of arc, we'll simply say that's the radius times the angle in radians. So that's 12 times the angle 0.723. So let's type this in. So this is going to be 8 plus 12 minus 8, which is 4, then plus 12 times 0.723. And what we're going to get here to 3SF is 20.7. So we have 20.7 centimeters for our answer. Question number 10. A curve has equation y is equal to 1 over k x to the power of a half plus x to the power of minus a half plus 1 over k squared, where x is greater than 0 and k is a positive constant. So on A, it is given that when x is equal to a quarter, the gradient of the curve is 3. Find the value of k. So here, what we are going to do first is we're going to find dy by dx, the gradient function. So we're going to start with 1 over k of x to the power of a half. Now 1 over k is a constant, so we have 1 over k of a half of x to the power of half minus 1, which is minus a half. And that's plus, here we bring down the minus half, then we have x to the power of minus half minus 1, which is minus 3 over 2. Then if we differentiate 1 over k squared, which is a constant, we get 0. So let's simplify this a bit. So here we're saying we've got 1 over k of 1 over 2 of x power minus half, which is 1 over x to the power of a half. And that's plus, here we've got minus 1 over 2 times 1 over x to the power of 3 over 2. So we can simplify this too. That's 1 over 2kx to the power of a half. And that's minus 1 over 2 of x to the power of 3 over 2. So this is what we have. Now, according to the question, they say it is given that when x is equal to a quarter, the gradient of the curve is 3. So we're saying when x is equal to a quarter, dy by dx is equal to 3. So let's see how we can work around that. So therefore, this means we'll be having 1 over 2k of x to the power of a half, which is a quarter to the power of a half. And that's minus 1 over 2 of x, which is a quarter, to the power of 3 over 2. And this should be equal to 3. Okay, let's simplify this a bit. So now we know that a quarter to the power of a half is square root of a quarter, which is a half. And a half times 2k, we are going to get 1 over k here. And that's minus. Here, a quarter to the power 3 over 2 is like we say square root of a quarter, which is a half. And a half to the power of 3, that's an eighth. And 2 times an eighth is again a quarter. And then 1 divided by a quarter is 4. So we have it like this. And then if we add a quarter to both sides, then we have 1 over k is equal to 7. And then this means, therefore, that k comes out as a 7th. So this here is the value of k. Let's move on to part B. It is given instead that the integral from lower limit a quarter k squared to upper limit k squared of 1 over k x to the power of a half plus x to the power of minus a half plus 1 over k squared with respect to x is equal to 13 over 12. Find the value of k. Okay, so we want to perform some integration here. So I'll say this is going to be equal to, and integrating 1 over k x to the power of a half, I'll be having 1 over k of x to the power of a half. Here, integrating it, we get 1 of x to the power of a half plus 1, which is 3 over 2. And that's over 3 over 2. And that's going to be plus. Here, integrating, we get x to the power of minus a half plus 1, which is a half. And it's over a half. And that's going to be plus. Integrating 1 over k squared, we get 1 over k squared of x. So this is what we have. And the limits are a quarter, k squared, and k squared here. So let's simplify this. Now for this one, if we're dividing by 3 over 2 is the same as we're multiplying by 2/3. So we come out with something like 2 over 3k of x to the power of 3 over 2. And that's plus, we're dividing by a half. It means we're multiplying by 2. So it's 2x to the power of a half. And that's plus 1 over k squared of x. So the limits are there. So here we're now going to substitute k squared. So we have 2 over 3k, and we have k squared here, raising it to the power of 3 over 2, and that's plus 2 of k squared to the power of a half, and that's going to be plus 1 over k squared of k squared, and that's minus, here we now substitute a quarter k squared, so it's 2 over 3k of a quarter k squared, and that's to the power of 3 over 2, and that's going to be plus, here we have 2 of a quarter k squared to the power of a half, and that's going to be plus 1 over k squared times a quarter k squared, like this. Okay, let's simplify this. So k squared to the power of 3 over 2, we multiply the powers, we get k cubed, and if we divide k into k cubed, we get k squared, so we are left with 2 over 3 of k squared. Here, if we multiply the powers, 2 times a half, we get 1, so we're left with 2k. And here, we will only have 1 if we multiply 1 over k squared times k squared. So this is what we get here. And that's going to be minus. Here we've got a quarter k squared raised to the power of 3 over 2. So here we'll be saying the square root of a quarter k squared, which is half k, and we raise half k to the power of 3, and we get an eighth k cubed. So let's have that. So that's 2 over 3k of an eighth k cubed, and that's going to be plus, here we'll be having a quarter k squared raised to the power of a half. That's like square root of a quarter k squared, which is a half of k, and that's going to be plus, here we'll be having 1 over k squared times a quarter k squared. We just get a quarter. Okay, so we can simplify this a little bit more. So I'll write down what we have right here. So we have 2/3 of k squared plus 2k plus 1, and that's going to be minus, here we have 2 over 3k multiplying an eighth of k cubed. Now we know that 2 will divide into 8 to get 4, so we have 1 over 12, and k into k cubed, we get k squared there, so we have k squared, and that's going to be minus, here 2 times a half k, we just get k, and minus a quarter. Now this can simplify to 2/3 k squared minus a 12th k squared, so it's 2/3 minus a 12th, we get 7 over 12, so we have 7 over 12 of k squared. Then 2k minus k is k, then 1 minus a quarter, that's 3/4. Now from the question, they'd say that the integral should be equal to 13 over 12. So we're going to equate this to 13 over 12. So this is equal to 13 over 12. Okay, so from here, I'm going to multiply both sides by 12. So if I do that, multiplying this by 12, we get 7k squared. And this 1 times 12, that's 12k. And 3/4 times 12, we get 9. And that's equal to 13. And if we take everything to one side, we'll be having 7k squared plus 12k. 9 minus 13 is minus 4 equal to 0. Okay, so we can now solve for k. So I will factorize. So we have 7k here and k. And for factors of minus 4, I'll have 2 here and I'll have 2 here. And I'll have minus and plus. And this is it. So either 7k minus 2 is going to be equal to 0, or k plus 2 is going to be equal to 0. So here we get k coming out as 2/7, and here k coming out as minus 2. Now from the question here, they'd say that k is a positive constant. So we're going to make use of that. So we're going to take the positive value of k. So therefore, the value of k that we want is 2/7. And that's the answer right here. Question number 11. A circle with center C has equation x minus 8 squared plus y minus 4 squared equal to 100. So on A, show that the point T with coordinates minus 6 and 6 is outside the circle. Okay, so what we have here is a circle with center C, and we have a point T which we want to prove or show that it lies outside the circle. Now, to show that the point lies outside the circle, we will have to work out the length of CT. Okay, so let's do that. Now, the coordinates of C, which is the center, can be deduced from the equation. So these are minus of minus 8, so that's 8, and minus of minus 4, that's 4. So these are the coordinates of C, and we have T already as minus 6 and 6. So for the length of CT, so let's say CT squared, that's going to be 8 minus 6 squared plus 4 minus 6 squared. So this is going to be 8 plus 6, that's 14. So that's 14 squared, and that's plus 4 minus 2, and that's 2 squared. And 14 squared is 196 plus 4, that gives us 200. Therefore, we know that CT will come out as the square root of 200, which is 14.1. So 14.1 here. Now 14.1 is actually greater than the radius of the circle, which happens to be the square root of 100, that's 10. So therefore, this proves to us that the point T lies outside of the circle. So hence shown. Okay, let's go on to part B. The two tangents from T to the circle are drawn. Okay, so we have these two tangents on the circle here. So on B, show that the angle between one of the tangents and CT is exactly 45 degrees. Now, if you look at this triangle here, we know that AC is the radius of the circle, and that's 10. And we also obtained CT from part A to be the square root of 200, which was 14.1. So we can actually, with this right angle triangle, work out this angle here, which is the angle between the tangent and CT. So let's call this angle theta. So we can say sine of theta is equal to the opposite side, which is 10, over the hypotenuse, which is square root of 200, which means theta is equal to arcsine of 10 over the square root of 200. So let's type that in. So that's shift sine of 10 over root of 200, and we get 45. So we get theta as 45 degrees, and hence shown. Let's move on to part C. The two tangents touch the circle at A and B. So we have A here and B here. Find the equation of the line AB, giving your answer in the form y is equal to mx plus c. Now for the equation of the line AB, we are going to need the gradient of AB and a point on AB. Now let's start with the gradient of AB. in order for us to find the gradient of AB, we can start by finding the gradient of CT. Now we know the coordinates of C, that's the center, are 8 and 4, and T is minus 6 and 6. So for the gradient of CT, change in Y over change in X, we can say that 6 minus 4 divided by minus 6 minus 8. And this is going to give us 6 minus 4, that's 2, and minus 6 minus 8, that's minus 14. And we get minus a seventh here for CT, which means that the gradient, therefore, of AB should be the negative reciprocal of this. So that's going to be 7. So gradient of AB is 7 here. Now let us look for a point on AB. Now for a point on AB, we can make use of the fact that the two diagonals for this shape here should bisect each other, which means this point here also happens to be the midpoint of CT. So they're sharing this point. So let's work out the midpoint of CT. Now for the midpoint of CT, we are saying we add the x coordinates. So that's 8 plus minus 6, which is 8 minus 6, and we divide that by 2. And that's 4 plus 6, and we divide by 2. And this is going to give us here 8 minus 6 is 2, and 2 over 2, that's 1. And 4 plus 6 is 10, and 10 divided by 2 is 5. So we have the point as 1, 5. And that's the point on AB, 1 and 5. Which therefore means that we can now use y minus y1 is equal to m of x minus x1, using this as the gradient and this as the point. So we are saying here that's going to be y minus 5 is equal to 7 of x minus 1. And this eventually is going to give us y is equal to 7x, and here that will be minus 7 plus 5, which is minus 2. So this here is the final answer. Let's go to part D. Find the x coordinates of A and B. Okay, so for the x coordinates of A and B, these are the points where the line which we got to have the equation y is equal to 7x minus 2, and the circle which we got to be, or to have the equation x minus 8 squared plus y minus 4 squared is equal to 100 meet. So what I'm going to do is I'll solve this simultaneously by substitution. So for the equation of the circle, that's x minus 8 squared plus y, but in place of y I'll put 7x minus 2. So that will be 7x minus 2 minus 4. So that's 7x minus 6 squared is equal to 100. So let's simplify this. Expanding the brackets, we get x squared minus 16x plus 64. That's plus. Here we get 49x squared. Then 7 times minus 6 is minus 42 times 2. That's minus 84x. And minus 6 squared, that's 36, is equal to 100. So x squared plus 49x squared, that's 50x squared. And minus 16x minus 84x is minus 100x. Then 64 plus 36, that's 100. And if we subtract this 100, we get 0. So everything is equal to 0. So here I can factor out 50x, and I get x minus 2 inside the bracket. And then here it's either 50x is equal to 0 or x minus 2 is equal to 0, where x comes out as 0 here and x comes out as 2 here. And these are the two x coordinates of A and B. And that's how we do it.